If you like my dad's videos, please subscribe to QA Insights channel.
So I have pinned one link to the Clubhouse hallway. So please join that link. I'm going to draw some graphs to explain the concepts so that you can visually see what's going on when I explain. So it will be at the top of your hallway. So there will be a link to miro.com. So if you join, you can view my drawings, visuals. So let us get started. So thanks for joining everyone. So last week we have discussed about the open versus closed workload model. So today we are going to see about the continuation. We are going to continue with the same open versus closed, and also we are going to touch base the universal scalability law. So that's the today's topic. So before we go, so this week's sponsor, Redline 13. So if you want to run high scale load testing, please check it out, redline13.com. And without any further ado, let us jump. So last week I have mentioned about JMeter 5.5, right? Actually, it was supposed to release early Monday this week, but due to some regression defect, it got postponed, it got delayed. Actually, there is a bug in JMeter. If you open JMeter and run some couple of samplers, and if you navigate between the results in your view results tree, sometimes you will feel some lag. So it is not in all the versions of JDK. Certain versions of JDK only you will see this issue, mainly on Windows. So I don't use this particular version, so I'm good. But if you're using some 11.04 or something, then you may see some lag. Basically, it is taking more time to render the results. So that's the issue. So I think they are going to fix, or I don't know, the conversation is still going on. So most probably they will just mention the notes, the known issues thing. So that's the update for JMeter 5.5. And another update is I created a game called Perfdil. So I know many of you would have heard about the game called Wordle. It's a very famous game. It's a word guessing game. So there was one open source repository. So I forked it and then I reconfigured it for the performance related words. So after this session, I can send you the link. You can just play. It will be interesting. So you have to guess the 5-letter performance related word. For example, say trace, right? So we use trace in observability, right? So that's one of the example I can give you, but I have come up with a lot of other 5-letter words related to only to performance. So you can check it out, perfdil.versal.app. I have posted in LinkedIn also. You can just check it out. Okay, so let us recap whatever we saw in the last week. So last week we have discussed about open versus closed. So you need to be wise to select which workload model you are going to follow based on your application. So people usually, including me, in the initial days, we blindly follow the closed workload model for the open system, or vice versa. So we should not supposed to do that because the results will vary. So we already seen that. So open, to revise, so open model means think of like Amazon.com or any e-commerce website where people will land your page at any point of time in a random fashion, and then they will just enter into the queue just to process their request. So closed workload model, what will happen is you think of like a ticket master where you enter into the room or the session where you need to buy a ticket within a certain duration. So everybody will be there at any point of time. Say 100 users are there in the 15 minutes loop. So again 100 users will come on a 15 minutes loop. So all the load testing tools, if you are using JMeter or load runner, doesn't matter. By default, every model, by default, whatever you create, it is a closed workload model. Basically, it will create a feedback loop. You send a request, it will process it, then only you can send the another request. So it is not like you can send 10 requests at the same time and all the 10 requests will process. No. So one thread, one user, it will send one request. After getting that response only, you can send another request for the same thread. So this is the closed workload model. So if your application is in open system, so what by default people will do is they will implement the closed workload model. So the response time will be better, but in production it might give you some other detail. I mean, some other worst response, or vice versa. Might be in stage you will get say 1 second. In production might be some 500 milliseconds, or vice versa. So it depends on how you plan, and depends on your architecture, everything. So that is why we need to be aware of these differences. So I already mentioned about the last week. There is a tool called Stormforge. So Stormforge, by default they support open workload model. So, but you can also do the closed workload model, but by default open workload model. Again, JMeter, Load Runner, these tools supports closed and open both. But by default, whenever you run with the default settings, so that is closed workload model. For example, thread group in JMeter. So if you run thread group, it is closed. For open, you need to go with, say, concurrency thread group or throughput controller. So you have to go for the different variety of the custom thread groups. Similarly, in Load Runner, whatever you do, it is closed workload model. And again, there is a different scenario you can design for the open workload model. So you need to be very wise among these two, so that you are testing the right thing for your application. Otherwise, results will vary. So these are the things we have seen in the last week. And for the open workload model, the graph would be like a hockey stick. So if you keep a hockey stick, so it will just flat, then there will be a curve, right? So that is the pattern you will see for the open workload model. But for the closed workload model, the response time will go steep. So it will start small, then it will go like a linear kind of a pattern will be there. So that's what we have seen in the last session. So in last session, again, we have made a lot of assumptions because everything is theory. So whatever we have seen, it was theory. So we have seen about pKa law, and then we have seen a little bit about Little's law. So closed workload model gels with Little's law. Open workload model, you need to refer pKa law. So I will write a detailed blog post about this, whatever discussed. But again, there are a lot of other good posts are available in the internet, mostly white papers. So if you are interested in reading white papers, definitely you can search. You will learn a lot. But I'm going to write the abstract of this. I'm not going to touch any formulas. Just to layman terms, I'm going to explain in my blog post eventually. So using these models, open and closed, what we can do is we can find the maximum throughput. That is our objective, one of the objective, maximum throughput, and also we can improve the mean response time. So these are the things we usually see when we try to run our tests, right? So again, another assumption is single server. So whatever we have seen, these models, open versus closed, everything we have assumed like a one server only, like say for example Nginx. So assume that you have only one web server and then you are going to test it. So then you can use these formulas and then you can validate once the test is done. But right now the architecture is distributed, right? So how do we measure the performance of the distributed ecosystem? How we can plan for our production servers so that we can save some money, so that we don't over provision it, or we lose money by losing some customers by under provisioning. So that is where the universal scalability law comes into picture. So this universal scalability law designed by scientist called Dr. Neil Gunther. So he observed all these laws, Little's law, Amdahl's law, and then a lot of research by running different variety of systems, and then using Load Runner and JMeter. In his white paper, you can see these details. So he has run extensively a lot of tests. Then he worked on mathematical equations, and he has come up with the USL, Universal Scalability Law. So this Universal Scalability Law is architecture agnostic. So it doesn't matter whether you are using distributed or multi-tier, whatever you call, whatever the architecture. So this USL fits irrespective of the architecture and the framework, tools, whatever you call. So everything is agnostic. Okay, so this law will help us to plan, okay, how our system scales based on the say throughput, or your number of servers, or number of CPU cores, right? So these things you can feed into the universal law, and then you can come up with the some model. So without running any test, you can simply model your performance. Then you can run various tests in your stage environment. Then you can see, okay, how your model is fitting into that, so that you can plan accordingly. So everything whatever we are going to discuss is a model. So it is not a real thing you will get it. It's a theory. You have to run your test and see how it fits. So that is the our objective. So even before this, I never deep dived into these formulas, but after I think Siddhu was asking about capacity planning. So then I started, I think 2 months ago he was asking. Then I started slowly research. Then I got to know more information. So this is what I'm going to share in today's session. So any questions, guys, please raise your hand so that we can discuss. So I want to keep this as a healthy discussion, because I'm not telling, I'm not going to discuss anything on the formulas. So just a abstract I'm going to explain.
Yeah. Thanks, Navin, for bringing up and
Hi, sir. Yes,
keeping it
you are less
keeping
audible.
it in
Sorry.
mind.
Please,
Oh,
you have to, yeah.
I got sore throat.
Oh, okay,
So
okay, sure.
yeah, fine. Thanks for keeping in mind that regarding the capacity planning, and I'm expecting this universal scalability law more. More related to infra guys, and of course, we also involved in the infra
Yes, yes.
and capacity planning. I'm
Yeah,
expecting
I hope I
them
will
to
be able
have
to
a
answer.
performance engineering. Yep. Thanks.
Yeah, thank you. Okay, so now let us dive. So this universal law assume that you are working in a cluster of servers. Okay, we have multi-tier or distributed. So think of we are working on a cluster of servers, and this scalability law will help you to answer two questions. One is your target throughput, capacity planning, and then how your system scales, scalability. So these are the two main questions it will answer. So before we understand about this universal scalability law, first you have to understand what is Amdahl's law. So if you go to Google and if you just search for Amdahl's law, you will get a wiki page, and in the wiki page you can see what the Amdahl's law is. So I'll try to explain in a very easy way. So assume that you are slicing the beans, string beans, right, for cooking vegetables. So what you do is, what our moms or yourself, just to speeden up the process, what we do, we take a bunch of string beans and then we just slice it, just to save our time, and you can easily speed up the cooking process, right? So the same thing only it applicables for the in the Amdahl's law. So basically, to save your time, so what developers will do is they will run some of the programs concurrently. For example, say you have 8-core processor. So in the 8-core processor, you want to utilize all the 8 cores to calculate the sum of 8 million numbers, right? So what you will do, what usually by default you will go sequentially. So first number, second number, third number, and then you keep summing up. So instead of that, what we can do is you can split 8 million numbers into 8, and each core you will assign each million. So at the same time you start the addition process, so that it will you will save a lot of time. So right now, nowadays we have the Go based language, right? So where you can work on multi-core. So you will distribute the load among multi-core just to save the time. So instead of if it is taking say 1 hour for 8 million numbers, if you are distributing the load to 8 core, then it will be done within 10 minutes, right? So but 10 minutes is the constant. So that 10 minutes you cannot change. You cannot go below 10 minutes, right? So that is the core of Amdahl's law. Okay, so why Amdahl's law is coming into picture in USL is because Dr. Neil Gunther, so he took the Amdahl's law and then he inserted in the equation. So why he inserted is mainly because of the contention penalty. So you can Google this term. So contention penalty. So basically, uh, some of the things, right, you cannot do it concurrently. For example, say you have a database, right? So to insert a record to a database, first you have to connect, then only you can insert the record, then you have to close the connection. So this needs to happen sequentially, right? But you cannot parallelize this. Okay, at the same time I'm going to connect, at the same time I'm going to insert, at the same time I'm going to close, means it will not work like that. So few of the your application, you cannot parallelize the process. So that factor is the Amdahl's law. So this factor plays important role in the USL. So this is called contention penalty. So this, they have a equation called alpha n. So throughput, sorry, n stands for number of servers, and alpha is the this value. And then the next factor, what he is talking about, the crosstalk penalty. So again, you can Google this word crosstalk. So crosstalk means the handshake between multiple servers. So now we have a distributed server, right? So if a request comes, so that request will be will be talking to many downstream layers, right? So if it is talking too many layers, then it will take more time to process. So that is the gist of this formula. So he takes Amdahl's law and this crosstalk penalty, and then he formalized the USL. So these are the two core things you need to keep in mind. So there will be a contention, and then there will be a crosstalk. So if you are able to reduce these two things, you can scale your application linearly. So that is the total gist of this USL. Very simply I'm putting. I'm not talking about any formulas. This is what the USL is.
Sorry to interrupt, Naveen.
Yeah.
So small doubt here, though. So this contention penalty and cross talk penalty, it's like a contention penalty is basically a process of programs. It has to go be sequentially, like you said, and yeah, crosstalk you said like I mean, yeah, how much factor they impact in the scalability?
Yeah, that's what next is I'm going to talk about that.
Yeah, sorry.
Okay, so what I'm going to do is I'm going to, okay, I'm not drawing anything. Let me share one link. So this is one of the conference I got this link actually. So I just refactored it. Let me pin that link so that you can view that formula in a graphical representation. One moment, let me just pin that. The website is desmos.com.
Pawan is asking what is the law, universal law of scalability, Pawan.
Universal Scalability Law.
Yeah.
USL, that is the law. So let me pin that link. One moment. So I have to delete this old link. So I'm going to add another link. So please go to this link so that you can see how this actual law is working. So right now I'm on the law, and please go to this link, in the pinned link. It is at the top. So if you go to this desmos.com calculator, so no need to sign up, nothing. You can easily directly you can work on this. So in the left side we have one table, X column. So X column you can think of like a number of CPU cores, or you can think of like a number of servers. Any server, it could be app or web, whatever. On the right side you have the formula, actual USL formula. And in the row number 2, we have the variables C, and then we have S, we have K. So S is like a contention penalty, and K is the crosstalk penalty, and C is the concurrency or throughput, whatever. So if you just drag the C value, say for example 2200 or 2000, wherever. So if you see, the graph is linear. So you have to keep your S equals 0 and K equals 0. So keep these two variables 0 and C 2200 or 2000, whatever number is. So if you see the graph, it will be like a straight. Basically it is a linear. So this is what many of the CTOs or CEOs or whoever allocate funds, right? This is what they expect. Bang for a buck. It is like investment. So I'm investing $10, I'm getting back $20. But that's not the way stock market works, right? That's not the way gold works, right? Because there will be ups and downs. Based on what's happening around the world, your stock price will vary, right? So this is what people expect, but we don't get this in reality as well. So when Dr. Neil Gantak, so he talks about the three variants actually. So whatever you see right now, the straight line, that is called linear scaling. right? And if the scale is going upside of the linearity, basically if it is greater than the linear scaling, that is called superlinear. So there is a term called superlinear. A couple of systems work like this. For example, Hadoop. So using Hadoop, if you optimize everything, you can get a superlinear. Basically, you will get more bang for your buck. So if you invest $1, you will get $1.25 of return, or $2.25 of return. So you'll get more profit, like Hadoop-like systems. If you invest in that, you can bring that superlinearity, and you get a linearity. Then under this, sublinear. So most of the systems are sublinear when the server goes up, or CPU cores up, or number of throughput, number of users, so whatever is changing, right? So most of the systems are sublinear. So these are the three things he talks about in his white paper. Now what we are going to do is we are going to change the value of S. So S and K always between the value 0 to 1. Okay, so these are the efficiency. So again, if you search for USL calculator, or USL say Python or Go, there are a lot of implementations have been done on this USL. So if you go to that like any library or language, right, or a package, so you can go to any package and download that and feed your numbers, and it will automatically calculate the S and K, that efficiency factor, and then it will not go beyond 1. Okay, so now if you go to S variable and change it to say 0.1, right? Now if you see, your graph is sublinear, but it is good only. This is not a bad graph. This is good because we are talking only about contention penalty. Crosstalk penalty is 0. That is why you are getting this kind of a graph. Now I am going to change the value to K again, put some 0.01. So S value is 0.1, K value is 0.01. So I'm not going to change it to 0.1. We are going to change. But right now, configure C equals say 2000. Okay, and then put S equals 0.1 and K equals 0.01. Okay, so now you can see it is sublinear. Okay, now if you increase the K value to 0.1 as S, now you see your graph is worst graph actually. So in the x-axis, think of like a number of servers or number of cores, right? So now your graph is going up, and again it is going down, and it is consistent because the value of crosstalk penalty is heavy. Why it is heavy? Because it is talking too many layers. It is talking to too many components. Say assume that you have 3 nodes. So 3 nodes, if each of the node has to talk, it has to make 2 connections at least, right? So A, B, C, A has to talk B, A has to talk C, and similarly B has to talk A, B has to talk C. And think of like you have 100. So there's a formula again, the node algorithm will come into picture. So if you think of it, you have some say 50 downstreams, so everything needs to talk. So there are a lot of crosstalks will happen. So at that time your scalability will make a big impact with respect to crosstalk penalty. Say in a room, if people are talking against each other, the room will be noisy, right? Similar concept. So if the more distributed, the more crosstalk. How do you reduce the crosstalk? That is another thing. That is we'll see eventually. But crosstalk will happen. If there is a crosstalk, it will be heavily impacted in the USL law. But if you change the contention penalty to even bigger, the impact will not be much like a crosstalk penalty. If you want to see the formula, you can see it. But contention penalty, it impacts, but not much as crosstalk penalty. Because the formula is, I think, beta n square for the crosstalk, and then for the contention it is alpha n. So n square, so that is the impact it makes. So that is why the graph will go down even. I mean, this is worst graph actually. So I think there is a term called this, I forgot. That's it. I probably have to search again. So these two factors only plays an important role in your USL. So any questions?
Yes, Navid.
Yes.
Again, Siddhi here. Sorry, guys. If you have questions, please. If you feel like I'm interrupting, you can go ahead, ask anybody. But still, I have a question, Navid.
Yeah, sure.
Looking at this USL and example, it sounds like when the law is made, the systems were like not monolithic, like a single entire architecture or three-tier architecture, right? So, but how it will be applicable for now multi-tenancy, apps connecting together? So, how you imply this one here?
That's what does it. So this is agnostic in all nature.
Okay.
Say, for example, you want to validate your, say, you have an authentication service. So you want to scale that authentication service, right? So you can fit this law for that authentication service only
Yep. Sounds like a
and
plan.
see how it scales.
Sounds like a plan. So, yeah. Thanks, Navid.
Because you have a lot of components, it is not possible to end to end. There is no end to end like this, right? You want to scale what you have to scale, whether you want to scale app layer or database layer or web layer, right? So you have to take that component and you have to try to fit that.
Yeah. Thanks,
So that is
Navid.
why you have to run your tests using tools. That is why even Dr. Neelkandar also executed a lot of tests with different variety of applications, open, closed. So both of the things he executed, he did a lot of research. Then only he published this paper. So it's widely accepted. So even Facebook, Twitter, everybody uses this USL behind the scenes.
Then definitely it must have be, I mean, implemented in cloud as well, cloud like
Yes,
microservices
that's
cloud.
what it's agnostic in all, architecture agnostic, framework agnostic. I mean, they have a lot of things they have done. There are a lot of white papers has been published for database, for Hadoop. Yeah, Hadoop is so super linear. That's what I read, but I never get into the details. But this exercise reveals that there are super linear applications are available.
So did they mention like how Hadoop, I mean, overcome this by
Again, white
implementing
paper,
USL? Yeah. Okay.
white paper.
Got it.
I don't know the
Thanks.
details.
Yep. Thanks.
Yeah, thanks, Pavan. Thanks, Eldad, for joining. Please go ahead. Hey, Pavan.
I'm not sure. Hi, I'm not sure if it's my turn, but I
Yeah,
can just
yeah,
random.
you can go. You can go, please.
Yeah. So first of all, thanks for bringing up this USL model. Uh, I mean, I think maybe a couple of years back, I was like kind of praised on this by one of the technical architects. But however, the dynamics behind it was so complex because first of all we were just trying to move from on-prem to AWS cloud. And the cloud auto scaling mechanism along with the what is that called as, which has some booting factor, right, which is able to minimize the booting of the EC2 instances and scale up automatically, right, from
Correct.
the vertical scaling perspective. I think it's kind of adopting the same USL model as what you said. If I'm not wrong, maybe you can correct me if I'm wrong. The second thing is when we talk about the what you call, I mean, you just told us that Hadoop has a very uh, super scaling model, right? Super scaling,
Yes. Super linear. Yes.
super linear, right?
Yes.
So similarly, when we talk about this multi parallel processing, or the data or the message architecture, that's what we call, a lot of architects, I mean, a lot of architecture, if it does involve, let's say, camel framework or entity framework, right, which where it has to, I mean, it kind of deals with multiple parallel processing of what you call chunks of millions, I mean, chunks of data, either it is subset of millions or billions, right? So
Yes.
does that apply the same, I mean, does this, I mean, you clearly told us that this is platform agnostic, architecture agnostic, and then server agnostic, right? The
Yes.
platform agnostic,
Correct.
right? So should I be assuming that it also this same particular formula holds good for different types of parallel processing frameworks and architecture, irrespective of the the horsepower that load test is simulated. That's my question to you. I mean, should I just consider it as an assumption and go ahead with the solution, or I mean, is there any other factors to be taken?
Yeah. So when you try to apply this law, so what I have done is in the x-axis, right? You have to decide what you're going to keep in the x-axis. Okay, whether you are going to keep number of servers or number of users or number of CPU cores. Okay, so based on that you have to run your tests, or based on that you have to model your this USL. Then only you get a clear idea how to proceed to get the model output. Okay, so in the Dr. Neelkanth's white paper, so he has kept, I think, throughput in the x-axis. Okay, in the y-axis, number of virtual users. So if the users are increasing, how it is affecting the throughput. So he could be running in a one server, or he could be running in a multiple server. I don't know. Maybe I have to deep dive again in the white paper. So you have to model this. Okay, what I'm going to keep, what I'm going to get out of it. So you cannot mix and match. Okay, I am going to keep the number of servers, and again I'm going to apply to number of CPU cores. So that will not work, because x-axis is very crucial here.
No, but yeah, I mean, because when we talk about, see, I'm not Hadoop expert, but I just played around with Snowflake and Sumo Logic, and to a certain extent MarkLogic, because all these are NoSQL data warehouses, right? Part of the data lake. Mm-hmm. So they do have their own. I don't want it to be more technical discussion. I mean, probably we might kind of lose the track here, but. All I just wanted to say is, I mean, when you talk about X and Y axis, throughput with respect to users, even though realistically we say that the performance is in an acceptable range, where if your users do scale up over a period of time, then obviously the same amount of or maybe a desired amount of throughput is expected with a few variants, right? But however, there is it has a different contradicting statement to it, because we do have observed with our tests, say, because all these databases, right, all these SQL databases, they have their own algorithm to kind of apply all this logics, and then the scaling mechanism, which has its own complex way of dealing things. But when we, as a solution architects, or when we are actually trying to, what do you say, slice and dice the data and then benchmark the volumes for the concurrency and for the with respect to queues and interrupts, I think the behavior is not quite predicted, right? I mean, you would still see that the scalability kind of drops down, and then you would also see that the amount of indexes, right, whatever the indexes that is being kind of used by default. I mean, like, for example, MarkLogic uses, like, I don't know, maybe more than hundreds of indexes, but still there is a concern of scalability factor. So I think, yeah, I mean, I completely agree with you that it's up to us. We need to do some research on the white paper, and then probably see, because ultimately, it's all about us. I mean, we have to take this to development or architects, right? Just to confirm, and then just to be really anchored to our opinions or thoughts, saying, this is the reason why it is failing, right? This is the reason why the scalability is not.
See, no need to do your exercises. For example, if you are going with, say, PostgreSQL or any database, so you can go to that vendor page and then you can see about the scalability. So there are a lot of white papers has been published for multiple database. I have also read on a high level. So whenever people talks about the linear scaling, you have to ask a question. Okay, why? How it is linear? Because linear marketing is a marketing term, linear scalability. So there might be a lot of behind the statistics will be there. So how linear you have to ask, and you have to understand the real data. You have to ask for the data, how it is linear. You cannot simply buy the linear scalability from any sales engineers.
Okay, so how is this linear, this linear scalability, and I think it's got to probably there's a relationship with linear scalability in Moore's law, also, if I'm
I
not
don't know.
wrong.
I do not see any relation. I mean, I didn't come up with any relation with Moore's law with the USL. Probably could be there. I don't know. I have to check it out. But I have seen Little's law, Amdahl's law, and then Kingsman law and PK law. So these are the laws, and then these four laws I have come across. It has heavily impacts in this USL.
Okay, yeah, I think I'm concluding my my opinions here.
Yeah, I
Thank
mean,
you.
for database, again, lot of white papers I have come across when I was doing this research. You have to go through those white papers and have to understand. Hadoop has, everybody has this scalability white papers. So how scale, that is what we have to ask the question. They can say linear, but how linear is? Okay, hi Eldad, thanks for joining.
Hey, Navin, how are you doing?
Good, how are you? Thank you.
I'm good. I'm good. Yeah, again, awesome topic to bring up. It's very theoretical, but I think it's very important because you have to understand the theory, not just the practice.
Yes.
And it really takes me like 12 years backward. I started a class about distributive computing, and the first thing that we were introduced to is Amdahl's law. And
Okay.
yeah, it's very important because,
Yes, yes.
and it kind of ruined the course because the first thing you learn is that you can't scale up forever. You can't just add more machines and it's going to magically solve the problem because at some point it's going to hit the wall. I think that another thing to look also the load balancer itself, because very often the architecture is okay. You have authentication server, and now this authentication server horizontally scales. So you add more instances of that authentication server, and then you have a load balancer. And sometimes that load balancer has scalability problems. So it's another thing to look at. It's the infrastructure, not just the actual business logic behind it. So it's another thing. And again, it goes forever. You could look at it from the database. So the database also could have load balancing components. Redis, okay, if you use any cache, if you use IoT, they all have load balancing components, and they can also have scalability problems. They are also subjected to the same barriers or such issues.
Yes, yes, Eldar. Yeah, that's correct. So when I was actually I never modeled USL yet. Actually, I didn't get opportunity, but only worked on open versus closed. Even this also it's pretty new because a lot of mathematics involved in this. So we needed a lot of patience to understand. So whatever I mentioned, if you guys come across something conflict, so please let me know so that I can also learn along with you. But please bookmark these calculators. It will be very helpful for your future reference.
Hi, Navin and Eldad. I
Yes,
have a thought like this is, this USL feels and looks like it's not only, it's considering load balancers as also into the picture, I guess.
correct, correct.
So the way, let's take the example, go back and 2 minutes back, you said like throughput versus users doesn't matter whether where you're applying. So I think the name itself concludes like whether you're implementing, applying this as a one tenant or in the backend system or multi-tenants or complete overall. So the first point which you concluded like 8 million across 8 cores, like I think he's kind of following like divide and rule system, I guess. Divide and calculate and
Correct,
implement the rule
parallelism,
system.
yes.
Yep, that's what I feel that because, and yes, of course, the load balancer itself have the that talent to divide the load, across the it's again another topic, I guess.
Yes, actually, the load balancer definitely improves the scalability, as Eldad mentioned. So what I have seen is, by default, AWS and other vendors, right? They have different strategies, right, for load balancing, say round robin or best out of something like that. Some factor they will calculate, and then it will route to the request. So what I have seen is in many of the talks, people they recommend best of two random choices. So this is one of the strategy for the load balancer. So you have to pick up two randomly and choose the best among two. Even if you have 10 or 100, doesn't matter. Choose randomly to select the best out of two. That's it. So this will improve the scalability. That's what I have seen.
Yeah, there are plenty of ways to load balance, and whenever you see balancing that is not equal, because it should be equal or close to equal. If you see inequality, that could imply problems. So it's another thing you better look at to investigate unequal distribution with load balancers. And there are ways to do that. It can be very easily calculated. I gave such example, I think, a few weeks ago when we talked to Joey. I gave an example of how you could calculate even distribution between backend servers with load balancer. So there are ways to do that, and it should be accounted for.
Correct, yes.
And
also, I have seen in the discussion in the previous projects, previous companies and all. Okay, right now we are getting some throughput, X throughput. Okay, let us double the servers. We will get double the throughput.
Oh, no.
So
no, that doesn't
then
work.
I was thinking, okay, how come? I mean, it is not like investing $1 and getting $2 back.
No, it doesn't work that way. Well, it's like saying, well, if we are two parents, we have one child, it takes X amount of effort to raise that one child. So two child is 2X amount of effort.
Correct.
No, that's 4X amount of effort.
Correct. Definitely, downstream will impact. Downstream, it will go down. Throughput will go down in the downstream, even if you are increasing, say, web layer. So yeah, that will not work at all.
No, it usually won't work because just a very small example, you double the number of connection to the database. So who knows how that's going to affect performance?
Correct.
That was my point.
It's very complicated.
So
I
even
know.
if you think the load balancer is distributing exactly, I mean, like perfect, you think that your load balancer is perfect, but how the backend and systems are behaving, how they're scaling also matters,
Yeah,
right?
exactly.
I think this law, I mean, applied each layer, each tier, like
Yeah, any component that the traffic goes through is subjected to that law.
Yeah. Speaking of which, seems like you have how many kids you have? I'm just kidding.
I have one child and he's like 4.
You have 4x throughput with one child.
Yeah.
Okay.
Another point that you also have to take into account is you should always look at the. It kind of sounds like more of an SRE thing than like a site reliability. No, you should look at all the traffic that goes in production. If you have production environment, because sometimes you work on future projects that are not deployed yet, but the moment they are deployed to production, you should look at the traffic very carefully to see how it varies or deviates from your predictions, and then you can correct them. It should always be revised. It's the same as the workload models. The workload models are constantly revised as you look at the traffic in production environment. So these kinds of equations follow the same rule. They're revised all the time.
So you mean to say we need to, I mean, include, consider these kind of laws and when we are preparing the, workload model, right?
Yeah, it should be taken into account that when scaling up, it's not going to be linear. It's
Yes.
not. Yeah, this is what you should always think about.
Yeah, there is no linear scaling. I mean, it's a marketing term, might be, but most of the systems are doesn't scale linear.
No, it could almost never happen.
But I'm still kind of wondering how it will apply in terms of cloud. Today, there is a, in the LinkedIn, Scott Moore posted like we used to we used to talk a lot much about performance engineering in the cloud. Why it's not nowadays? So are they overriding us, something like that? I just kind of like that one. So, uh, how this law will be applied in the cloud, the connectivity and everything. That's what still I'm thinking about. You have any thoughts?
No, that's what I said. It is cloud agnostic, on-premise agnostic, whatever you say,
Yeah.
it is agnostic.
Exactly.
Like
Remember,
mainly the crosstalk penalty, right? So that talks about the distributed nature.
yeah,
Mainly the crosstalk penalty, because crosstalk means a lot of communication is happening between the upstreams and downstreams. So that is exactly the cloud is. That is exactly the distributed nature.
exactly. Cloud is just a metaphor. See,
Yeah.
remember that cloud is just a metaphor. Okay, there is no cloud. There's just someone else's computer. That's what it really is.
That is the
The
point.
cloud is just
That's the
a
point.
more efficient way.
Sorry to
Yeah,
interrupt. That's the
I'm
point.
sorry.
Yeah, that's the point I want to talk about is we don't know the
Yeah,
somebody else connectivity, somebody else connect crosstalk penalty. How much crosstalk penalty is going to, impose on our application? How do you figure it out?
That's what said. See, if you there is a Python package is available. Okay, USL Python. If you search in Google, you will get that package. Download the package and run some sample data, and see how these efficiencies is getting calculated.
Thanks,
It is
Naveen.
very simple because I
that's
have
great.
done that. So I feeded my JMeter throughput and the users. So it exactly matches the pattern basically. So it will not be like ups and downs like a peaks and valleys. No, it will be like a curve.
Yeah, thanks, Naveen. That
Yeah, and
explains.
also R package or any whichever language you are comfortable, definitely there will be a package. So and also I forgot to probably I can share this in LinkedIn. So there is a Khan Academy simulation is there. I can share it with you guys. So if you go, I don't have the handy, but it's in my account. I have publicly shared. So I took one of the project and then I just analyzed and then I published my own because that thing I don't know when they will take down. So I just took a copy of that. So that Khan Academy simulation exactly talks about USL, how your curve goes when particular efficiency is increasing. So it will show you the simple animation. So you can also see that to understand better.
Thanks, Naveen. It was kind of have a puzzle saying that how you calculate these penalties.
Yeah, that's what the USL Neil Gunther's paper. If you search USL Neil Gunther Excel or spreadsheet, you will get one Excel sheet. So there you can see these tables and formulas. So if you just feed the throughput the users, so everything will be calculated by the formula, and then the graph will be generated. So that is also you can try. So all are same. All are using the USL formula only. But yeah, whichever implementation you can go with that. That's what this is only theory, right? What time we discuss a theory. So reality, you have to run the test and see whether you are matching with the model or not. Because 1 million transactions you cannot simulate, right, in your stage environment. So you can run up to certain thing and then you can simulate. Okay, 1 million. Okay, this is what we will get. That's the idea of this USL.
Correct, Naveen. So before going to lab, you need to have a theory. Otherwise,
Yeah. So form hypothesis, run experiments, and try to whether it is proved or not. That is up to the results. That's okay. Today's participation is very less. I thought people will be joining. That is fine anyway.
Yeah.
Okay, guys. So that's it from my side. So we have anything to discuss? We can discuss. Otherwise, we can wind up.
uh, I have a question, Eldad and Naveen or Shiva. Anyway. So did you people anytime? I think it's a completely out of topic. Captured like GC logs or thread dumps and heap dumps from any PCF
Yes.
cloud container.
Yes. Of
Yes, I
course.
do. Yes.
How did you do that? So you people contacted with the PCF guys, or you did? So are they writing the logs to some Splunk or somewhere you are getting? How?
No, you should work closely with your DevOps team or whoever sets up the environment. If it happens to be the DevOps team, so be it. and they can give you access to the machines, and you can just sample one or two of them and take the GC logs and the thread dumps and heap dumps and whatever needed, and then you can, well, if you have a Java-based application, of course,
Okay.
it's pretty
So
much straightforward.
yeah.
You're missing
So
we
usually
don't have
what I
access.
do, usually APM tools, sorry, observability tools,
Yeah,
Dynatrace
yeah.
and Neuralink, you can take the dumps from the UI itself, if there is if it is enabled. Otherwise, there are certain tags you can pass it in your JVM arguments. Suppose, say you are seeing some GC, the heap, the memory issues. So you can pass a few of the arguments, JVM, like out of memory error, some plus XX, right? So if you pass it, whenever crash happens, memory out of thread, that thing happens, it will automatically take the dump and it will keep it in your that local instance. Then you can ask the DevOps guys or somebody, okay, you can ask for them and then they can share it with you.
Yeah.
Nice, nice. So, but
So Neuralink doesn't support heap dump. I never seen in Neuralink. Neuralink supports the thread only. So you can profile the thread from the UI.
Yeah,
You
and
can analyze it from the UI.
I think it makes sense because the heap dump would really hold all the system,
Correct.
and it's very risky to do that. If you accidentally do that in production, ouch, that would not be very pleasant. Yeah, so maybe there should be some more safeguards around heap
Yeah.
dump, but thread dumps you can do that with no problem.
Yes. And Dynatrace supports two flavors actually. There are two modes. One is the as Eldad mentioned, the deep dive, I think something called deep dive or deep lens something. So that will heavily stops your JVM. And there is some other flavor. It will not much have much overhead, but yeah, I don't recommend it from the from any tool. Only thing is you have to pass the argument and automatically takes it.
yeah, and there is this actually the problem which I'm facing is like one of microservices deployed into the prod, and they didn't follow the settings what we suggested in actual our in lower, and they kept all defaults, and the heap was instead of 1 gig they kept to 300 MB, and which triggers, and unfortunate thing is like there is no logs, and we don't have any access, they are not writing to any logs or something, and we don't even know. I connected with Ram Lakshmanan regarding GC. So the problem is like five full GCs was happening in a minute. So we don't know what kind of GC they have. Then Lakshman suggested like what Java version you have. Then we said Java 8. Lakshman said like Java 8 update with 40 if you don't mention any GC algorithm in Java arguments. So it will blindly take the G1 GC. But
Yeah, it is by
that
default is G1 GC,
Yeah.
Java 8. And
no, I mean
also,
that's
Sid,
too
what you can
long.
do is, you mentioned, right, minimum and maximum, always keep the values same.
Yeah, that's
Minimum 1 GB
that.
is maximum 1 GB. So do not configure minimum one value and another value is maximum.
Yeah, actually, we suggested 1 gig, but they went to 300. That could be the possible reason why full GC is happening because of minimal heap, and and that is wrong. I proved because the Java version I have, Java 840 above than that it will go G1 GC. That's what Lakshman suggested, but
I
the
think it's
version
the
what
same for Java 11.
yeah, true. Above means the two, right? Java 840 above
Oh,
plus
okay.
Java 11. So, but the JVM version, I could see that Java 8 300 something. Update 300. But still, it is throwing the parallel GC. It's not showing G1 GC. There are a lot of things we have to deep dig into that. So, yeah, what suggestion we said like whatever Naveen said like just go for increasing the heap what we suggested. Yeah, that's what kind of happening. And the PCF guys, they didn't give the access. There is no direct point of contact. All we have option is to create a ticket in Jira. Yeah, we kind of digging
Cool.
in. Thanks Eldad and thanks Naveen.
Yeah, no problem here.
So I didn't know that we can connect to that containers and get the heap and thread dumps. At least in the lower piece in performance environment, we can add those arguments and get the dumps. Yeah,
Yes.
thanks.
Thank you. Okay, thanks for joining, and see you next week with a different topic. And you can hear the recordings from this Clubhouse app. So thank you. Have a good weekend. See you.
Goodbye.
If you like my dad's videos, please subscribe to QA Insights channel.